don't you worry, child. She heaven's got a plan for you. Don't you worry now. Yeah.
Don't you worry, Sully is back. Unit 2, Algebra 2. We're gonna start off with function notation here, alright? Look down here. Oh, this is way too much, Mr. Kelly, as we can all look out, especially with this creepy smile. Alright, see what that's all about. We'll get back to that in a bit. Let's start out with something you already all know how to do. This is something that, you maybe have forgotten, but we definitely know how to do this. So wherever I see y equals 2x minus 4, I want to plug in x is negative 3. So wherever I see x, I'm going to plug in negative 3. So 2 times negative 3 minus 4. Y equals negative 6 minus 4. And then again, that of course is y equals negative 10. No big thing. We all know how to do that. That's just evaluating. We could have had this been anything we wanted. Squares, square roots, all sorts of fun stuff. You guys know how to do that. Let's kick it up a notch though, alright? So, here we go. Function notation. Function notation is a different way to write what we've already written. Usually we write y, now we're going to write f of x. Y is the same thing as f of x, and it's read f of x, not f parentheses x, it's read f of x. It's the value of a function when x is a certain value. So I'm going to plug in my x, and it's going to spit out the value of the function at x. Okay? Now, it's just another way to write things. So we kind of need to get used to writing things this new way, and that's not a problem, all right? If we take a look here, we have 2 coordinate points, an x and y, all right? We want to write them now in terms of function notation. And again, it's just y equals f of x. So instead of x, I'm going to put my x here. So f of 5. So the value of this function when I plug in 5 is 7. So f of 5 equals 7. It's the same thing as the point 5 comma 7. Alright, I just plug in my x and my y. So here we go. F of what is my x here? My x is 0. I plug it in, and what is my output? My output is negative 5. What I put in, my x, what comes out, my y. It's just a new way to write things. Alright, I understand sometimes people are like, why do we need to do this? It's more descriptive. Alright, well, I'll show you in just a second, but it's just definitely more descriptive. If you take a look back, right here, y equals negative 10. Is that a point? No, I have to look up here and say, alright, this is y is negative 10 when x is negative 3. With function notation, everything's already described for us. The value of x is here, the value of our y is right there. Alright, we could also have, we could go from function notation to a point. Easy enough. We know this is 6, and our y is negative 10. Our g of x, see, now here's the thing. We're going to throw a lot of different things. Traditionally, f of x is function notation, but it doesn't have to just be that. It could be anything. It could be g of x, could be g of n, different things like that. We'll talk about it. It's all the same thing. One's going to be an input, your x, your input is negative 6, and what is your output? 0. That's all we're talking about. All right? Let's try it now. Let's try a problem here. So this is a similar problem to what we had. We want to find f of negative 4. So wherever I see x, I'm going to plug in negative 4 because this is f of x. So here I come over here, f of x, this time it's negative 4, equals negative of, what is my x? A negative 4 minus 7. A lot of people are like, well, there's 2 negatives there. The x, this negative was already here. I had to just had a fluke that this time my input, my x had a negative as well. All right. So f of negative 4, let's evaluate. A negative of a negative is a positive 4 minus 7. 4 minus 7 is negative 3. So this is f of negative 4 equals negative 3. And every time we have one of these answers, we want to express it in function notation. All right. Every time, that way, all our answers are going to look exactly the same. Alright, so in this one now, this is what I was talking about. This is h of a. This is the function h in terms of a. So wherever I see a, in this case, I'm going to plug in a negative 3. So here we go. So h of negative 3 equals 2 times negative 3 to the third minus 2 times negative 3. Now we just have to evaluate this. Negative 3 to the third power, negative 3 times negative 3 times negative 3 is a negative 27. We can do this. Negative 2 times negative 3, well, that's a positive 6. 2 times negative 27 is negative 54 plus 6, which is negative 48. Seems like a good answer right here, but remember, we want to write it in terms of function notation. This is more descriptive. So h of negative 3 equals negative 48. So I know that when I put in negative 3, my output is negative 48. Let's take a look at this next one. Ooh, we have a radical. Excellent. So, typo self, and that's to be g right there. So g of b equals 3 radical 2b, find g of 30. So wherever I see b, I'm going to put a 30. So g of 30 equals 3 radical 2 times 30. And 2 times 30, of course, is 60. We need to reduce this. All right, let's see. 60 is, I need a perfect square that goes into 60. Radical 4 times radical 15. The square root of 4 is 2. So now I have 3 times 2 times radical 15. And, of course, 3 times 2 is 6 radical 15. We need to make sure that we write it in function notation. So g of 30 equals 6 radical 15. And if you need more help on radicals, we've been doing these probably in Back to Basics in your class, hopefully. This, you can go to the Algebra 1 section, all right? On the Algebra 1 section, it's all the way in Unit 12. Unit 12 will talk more about how to simplify radicals if you need extra help, because you know we're going to ask you these questions and we kind of expect that you know how to do it, all right? So now we have this in terms of g of x equals the absolute value of x minus 1 minus 2. We have a table and then we have a graph. So what we're going to do right now is we're going to complete this table and then we're going to graph some points and see what we get. A table is just, you know, doing the same problem several times. So let's see here. The first time I'm going to plug in for x is 1. So the absolute value of 1 minus 1 minus 2. So 1 minus 1 is 0. The absolute value of 0 is 0. 0 minus 2 is negative 2. So this is like the point 1, negative 2. So 1 over, negative 2 down. Okay? Plug in negative 4. So the absolute value of negative 4 minus 1 minus 2. Let's see what we get. Negative 4 minus 1 is negative 5. Absolute value of negative 5 is 5. 5 minus 2 is 3. So negative 4, 1, 2, 3, 4, and then up 3. And last but not least, we have 5. Let's plug in 5. So we have 5 minus 1. Absolute value of 5 minus 1 is 4. 4 minus 2 is 2. So 5 over and 2 up. And if you remember from algebra, these are, in fact, V-shaped. All right? But again, this just reinforces the point that function notation is nothing new. We could have done this, and this could have been y equals absolute value of x minus 1 minus 2. We could have gotten our points just like normal and plotted them. It's nothing new. It's just new notation that is going to take a little bit of time to get used to. All right, but that's not the only cool thing about function notation, all right? Now we have it a little bit different. We have our function right here, f of x equals 2x over 3 plus x over 4. We want to find the function, the value of x when f of x is 22. All right, so instead of plugging in x, see right now I don't have an x to plug in. I'm going to plug it in for this whole thing, f of x right here. So where is that? It's right there. So instead of f of x, I'm going to put 22. 22 equals 2x over 3 plus x over 4. Now, if you remember, Mr. Kelly showed you that trick. We want to get a least common multiple between 3 and 4, and that is 12. So we're going to multiply everything by 12. 22 times 12 is 264. 2/3 times 12 is 8x. 1/4 times 12 is 3x. Combine these, we have 264 equals 11x. Solve for x and divide both sides by 11, and you should get 24. Now that says x equals 24, but we know we need to put this in function notation. Remember, f of x equals y, right? Well, we know our f of x is 22, our y is 22, and we know now our x is 24, so f of 24 equals 22. So now you can see, doesn't matter what way we do this, we're going to have to put that in function notation at the end. All our answers are going to look the same. The great thing about function notation is it works for all sorts of functions, all right? In this case, we have absolute values, so instead of k of b, what are we going to put? K of b is 15, so 15 equals the absolute value of 2b minus 3 minus 2. Now we're solving an absolute value equation, which again, we've learned before. We're going to solve for the absolute value, get them by themselves, add 2 to both sides. So now I have 17 equals the absolute value of 2b minus 3. Remember, when we have the absolute value, we create two equations. One is the opposite of our answer, negative 17 equals 2b minus 3. And one is exactly that answer, 17 equals 2b minus 3. Add 3 to this side, I get negative 14. Divide by 2, and b could be negative 7. Add 3 on this one, we get 20 equals 2b. We can divide by 2, and b would be 10. Now again, we need to write this in function notation, so I'm going to write it up here. F of b, what's our b? Negative 7, oh excuse me, this is a k. K of negative 7 equals 15, or k of, what's our other b? 10 equaled 15. Two answers for this one, so I put both function notations in there, all right? Look down here, we have h of n equals n squared minus 2n. Instead of h of n, this time I'm going to put 8. So I have 8 equals n squared minus 2n. This is a quadratic. Remember, from solving quadratics, we've got to get all our numbers on the same side with the n squared. So I'm going to subtract 8 from both sides. So now I have 0 equals n squared minus 2n minus 8. I need two numbers that multiply to negative 8 and add to negative 2. So that is n plus 2 and n minus 4, because negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. Now I have two equations. Set these equal to 0. This is that 0 product property. Subtract 2 and n could be negative 2, or add 4, n could be 4. Not good enough. We need to put it in terms of function notation. So h of negative 2 could equal 8, right? Or h of 4 could equal 8. All right? Now I know that factoring, again, here's another one. This is a skill that we do in the Back to Basics. If you need more help with that skill, it's in Algebra 1. All right? Go to Unit 10 on Flip Math. It'll talk about factoring, and then there's 6 sections in Unit 10. I believe it's 4, 5, and 6 talk about factoring, just in case you need more help. But again, that's assumed knowledge. We assume you know that. You were taught it in Algebra 1. You should really know how to do that stuff. That's why we're doing those Back to Basics. Hopefully you're paying attention and get better at them. Now we have a graph, okay? Now we have a couple of different things we have to do. For this one, we have to plug in for x, negative 1. So f of negative 1 equals negative 1 squared plus 2 times negative 1. Negative 1 squared is 1. 2 times negative 1 is negative 2. So f of negative 1 is negative 1. So I'm going to plot that point, negative 1 right there. All right. And then we have 0. So now f of x equals 0. So I have to set that equal to 0. So 0 equals x squared plus 2x. This is another factor. This is a greatest common factor. The greatest common factor between x squared and 2x is x. Take an x out. Take an x out. Two answers, right? So x could be 0, or x plus 2 could be 0, which means x would equal, subtract 2, negative 2. So we have two answers on this one. Oh, so I'm going to make another little thing on my table here. For 0, I could have two answers. I could have 0, 0, or I could have 0, negative 2. So let's plot that. 0, 0 is right here, or 0, negative 2, or negative 2, 0 is right here. All right? Let's do 8. So for 8, 8 equals x squared plus 2x. Subtract 8, so we can get 0 by itself. Looks like we're going to have to factor again. So I need two numbers that multiply to negative 8 and add to 2. X plus 4 times x minus 2. We have two answers, so x plus 4 equals 0, or x minus 2 equals 0. Subtract 4, and x would be negative 4. Add 2, x would be 2. So for 8, another one, we have another one we need to put down here. We have two answers for 8, and they are negative 4 or 2. So we can do that negative 4 over, and then 8 up right there. And we have 2 over and 8 up right there. Now this is called a parabola, and it's not quite the same thing as absolute value. It's a U shape, even though it's hard to tell from my drawing. It is in fact a U-shaped figure, alright? Alright, so this brings us to this really big one. F of x equals 2x plus 3x minus 5x all over 4x squared. And we want to find F of Kelly. Holy cow. So wherever there's an x, I'm going to plug in a Kelly here, hopefully. So let's plug in a Kelly. Come on, Kelly. There. Let's plug in a Kelly there. Oh, yeah. This is a little... He's looking at me. He's looking at me. He's not sure what's going on. He's looking at me. Boom. So let's see what the value of this function is when we plug in Mr. Kelly. All right? What do you think the outcome of this is? So we have 2 Kellys plus 3 Kellys. Well, that is 5 Kellys, right? Minus 5 Kellys all over 4 Kellys squared. So let's put those in there. Mr. Kelly doesn't want to cooperate, just like always. Now check it out. Let's see what we can do. 5 Kellys minus 5 Kellys, well that is 0 Kellys, which is the same thing as just 0, right? And does it matter what 4 Kellys squared is? It doesn't matter. It could be blah, 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 because 0 divided by any number is 0. And of course, we should have known from the beginning that when you input a Kelly, nothing happens. The man does no work. He's been feeding off the rest of the algebras for years. The value of Kelly is 0. Just kidding, Mr. Kelly. You know we think the world of you. Born and bred algebra, one of the originals. All right? So I want you to try these home slices, see what you get. And in a second, I will post the answers and we'll go over them. So check your answers. Over here, we plug in 20 for x. 4 times 20 is 80. 80 is the square root of 16 times the square root of 5. Remember, we want a perfect square, and the perfect square of 16 is 4. 4 times 4 is 16 radical 5. So f of 20 equals 16 radical 5. On this one, we have to solve, right? We change h of n. We made another mistake, Sullivan. To 11, so this should say h of n. So subtract 3 from both sides. 8 equals negative 4n. Divide, and you get negative 2. And then, of course, the value of the function of negative 2 equals 11. All right, I'm going to leave you off with one of the great motivational speakers of our time. Well, not so much your time, but the algebra's time when we were growing up. This is one of the great motivational speakers. I hope you feel motivated to go out there and really do great things. And I will see you, as always, on the flip side.